In this module, we will be learning about international units of measurements. Any physical quantity such as length, mass, or time is measured and denoted in terms of their standards called a unit of measurement. A unit is an internationally accepted basic reference standard against which the measurement of any physical quantity are compared. In physics, we deal with many physical quantities and their units. However, very few basic units are required to express these physical quantities. Most physical quantities are expressed in terms of some base quantities. These base quantities are referred to as fundamental quantities. For example, distance, which is a measure of length, is a fundamental quantity. It's the same with time. The other quantities, which are expressed in terms of their fundamental quantities, are called derived quantities. For example, area or volume, which is expressed in terms of multiples of length, is a derived quantity. Similarly, speed is a derived quantity, as its measurement depends on distance and time. The units of fundamentals or base quantities are called base units or fundamental units. The units of derived quantities are expressed as a combination of base units. Such units are called derived units. Base units and derived units together make up a system of units. A system of units is generally accepted set of units of measurements. Until recently, three major systems of units were in use in different countries based on the units of three fundamental quantities, namely length, mass, and time. Among these were the CGS system, which stands for centimeter, gram, seconds, and FPS, which stands for foot, pounds, seconds, respectively. These units were adapted by Britain and hence the system is referred to as a British system. The third system of units is the MKS system, which stands for meter, kilogram, and second. However, in 1971, the General Conference on Weights and Measures recommended a standard set of units of measurements with their symbols and abbreviations. This system is known as Système International des Units, French for International System of Units, abbreviated as SI. Currently, SI units are followed globally for all scientific, academic, commercial, technical, and industrial purposes. In SI, there are 7 base units for the 7 physical quantities taken as fundamental quantities. Following are the quantities and their corresponding units. Length is measured in meters, denoted by the small letter m. Meter is the length of the path travelled by light in a vacuum during a time interval of approximately 300 millionth of a second. Mass is measured in kilograms, denoted by small letters kg. Kilogram is equal to the mass of international prototype of the kilogram, a platinum radium alloy cylinder kept at International Bureau of Weights and Measures in France. Time is measured in seconds, denoted by the small letter s. A second is the duration of approximately 9 billion periods of the radiation, corresponding to the transition between the two hyperfine levels of the ground state of the cesium-133 atom. Electric current is measured in ampere, denoted by the capital letter A. An ampere is that constant current which, if maintained in 2 straight parallel conductors of infinite length of negligible circular cross-section and placed 1 meter apart in a vacuum, would produce between these conductors a force equal to 2 multiplied by 10 raised to the power minus 7 Newton per meter length of the conductor. Thermodynamic temperature is measured in Kelvin, denoted by the capital letter K. A Kelvin is a fraction, 1 over 273.16 of the thermodynamic temperature of the triple point of water. Luminous intensity is measured in candela, denoted by the small letters CD. A candela is the luminous intensity in a given direction of a source that emits monochromatic radiation of frequency 540 into 10 power 12 Hz, and that has a radiant intensity in that direction of 1 by 683 watt per steradian. An amount of substance which contains as many basic entities such as atoms or molecules in a system as equivalent to the number of atoms in carbon in a 12 isotope is measured in mole, denoted by the small letters MOL. Apart from these basic units, SI has defined two more units for two supplementary quantities, namely plane angle and solid angle. Plane angle d theta is the ratio of length of an arc of a circle to the radius of the circle and is measured in radian, denoted by small letters RAD. It is defined as the angle subtended at the center of a circle by an arc of length equal to the radius of the circle. Solid angle is defined as the ratio of the intercepted area dA of the spherical surface, described about the apex O as the center, to the square of its radius r, and is measured in steradian with the symbol SR. If the magnitude of the intercepted area is equal to the square of the radius, then the solid angle is equal to 1 steradian.